Hello everybody. This video is going to kind of follow up with the other videos, and what I'm talking about today is kind of the battery banks is a major part of this, but also the inverter, the machine that's going to actually change your DC power from your battery bank to your AC power that your appliance is going to use. Importantly, if you're going to use, maybe just a few things like some lights or something like that, if you were to use, maybe 6 LED bulbs that ran about 9 watts a piece, which is about 54 watts, we would take that 54 watts, divide that by 0.8, which is, like I said in our previous video, the D-rate factor, what we kind of lose in changing everything, which gives us 67.5 watts is what we would need to run 6 LED light bulbs running at 9 watts a piece. So we may go with something smaller like the 400 watt inverter. And it might run something like 12 volts. So in order to get 12 volts from something like 8 battery packs, or 8 batteries running at 12 volts a piece, assuming each one of these is like a car battery, 12 volts a piece, we would connect them in parallel, which means that we would connect the positive terminals to each positive terminal all the way across, and then connect positive terminals that way. And what that would do is that would give us a constant output of 12 volts would stay completely the same. 12 volt output would stay the same. But if you wanted to go something larger, like maybe powering your house or a small tiny house or maybe a room in your house, you might want to go with something like a 2000 watt inverter. And that may run something like 96 volts. So in order to achieve that 96 volts from 8 batteries, we would have to kind of daisy chain them together, which means that we would have to connect these batteries, positive terminal, and we would have to take the negative terminal and connect it to the positive terminal of the next battery, and so on and so forth. So negative terminal to positive, negative, positive, across, and then negative, positive, leaving us 2 terminals left, a positive terminal on one side and a negative terminal on the other side. Now adding all these batteries together in a chain bumps the voltage up by 12. So each time that we add a battery and link it together in this way, the positive terminal, negative, and then linking the negative terminal to a positive, negative to positive, and then daisy chaining them together across, bumps our voltage up each time. And for example, 3 of those would be 36 volts. Whereas staying constant across the board, keeping all of our positive terminals connected on one side with all the negative terminals on the other side, keeps it a constant 12 volts and just stays the same. And that's kind of just something I wanted to go over with people who are considering going to solar power, what inverter you might want to consider, and also how to kind of look at the linkage of your battery